Ever stop and think about the secret life of your packages? You know, the incredible, invisible journey they take to get from some warehouse to your front door? It's a story told not just by trucks and ships, but by this silent, powerful stream of data. Today, we're going to pull back the curtain on the evolution of tracking tech, from a simple barcode scan to a supply chain that's practically alive.
It all starts with a number, 1 in 300. What is that? Well, that's the guaranteed error rate when a human has to manually type in a long, complicated product code. Now, I know, it might not sound like a huge deal, but in the world of logistics, that's the original sin, the absolute enemy of efficiency.
So, okay, how much chaos can one little typo really cause? Think about this. A modern warehouse is a beast, handling tens of thousands of items every single day. That 1 in 300 chance, all of a sudden, it translates into thousands of packages being lost, missorted, or shipped to the wrong continent every single day.
And that leads us perfectly into our first chapter, the battle against what you could honestly call the billion-dollar typo. This is ground zero. This is where the fight for an automated, error-free supply chain really began.
The solution that came along was just elegant. So simple, yet completely revolutionary. Automatic identification in the form of the humble barcode. Its whole purpose in life was to take human error out of the equation. Just let a machine do the reading.
But here's the thing you have to know. Not all barcodes are created equal, not by a long shot. So now let's look at how this simple idea of lines on a box evolved from something you see at the grocery store into a data-rich powerhouse for global logistics.
Okay, so what you see on the screen here is crucial. On the left, you've got your standard retail barcode. It just says, hey, this is a box of cereal. But the logistics code on the right, whoa, that's like the product's passport. It doesn't just say it's cereal, it tells the system which specific batch of cereal it is, when it expires, its weight, its lot number, its entire life story.
And this is how it works. It's brilliant, really. A single scan of that one logistics code breaks down into all these different pieces of critical information. You get the product type, you get the expiration date, and you get the batch number. This is what makes strategies like FEFO, first expired, first out, possible. It makes sure that the oldest stuff gets shipped first so nothing spoils. All from one quick zap of a scanner.
But you know, these long, one-dimensional barcodes, they have a physical limit. They can only hold so much data before they become ridiculously long and unwieldy. So what was the solution? Well, stop thinking in lines and start thinking in squares. By adding a second dimension, these new codes, like the data matrix, can store thousands of characters. And that enables something truly incredible, tracking every single item, not just the batch it came from.
But here's the catch. Every single barcode, whether it's 1D or 2D, shares the same fundamental weakness. And this next technological leap we're about to see was designed to solve that one problem by, well, basically cutting the cord, or more accurately, the line of sight.
The problem is so simple you've probably run into it yourself. To scan a barcode, you have to see it. If the label is torn, or smudged, or just happens to be on the wrong side of the box, you're out of luck. RFID totally changes the game by using radio waves. It doesn't need to see the product. It can literally read a tag right through the cardboard box.
So RFID basically comes in two main flavors. You've got passive tags, like the security tags on clothes. They have no battery. They get their power from the reader's radio waves. They're super cheap and work up to about 15 meters. Then you have active tags. These guys have their own batteries, so they can shout their ID from over 100 meters away. These are for tracking really high-value assets, like entire shipping containers in a massive port.
And the advantages here are just, they're game-changing. Seriously, picture this. A forklift is driving a pallet with 100 boxes on it through a warehouse gate. With RFID, the system scans all 100 of those tags in a single second. No stopping, no scanning each box one by one. And these tags are way more durable, which unlocks incredible levels of automation. Like drones that can fly through a warehouse overnight and do a full inventory count with zero human help.
So if RFID is so amazing, why isn't it on everything? I mean, why isn't it on my can of soda? Well, the answer, as it almost always is, comes down to money. A barcode costs a fraction of a penny. The absolute cheapest RFID tag is around 8 cents. Now, that difference is nothing when you're talking about a pallet of TVs, but it makes zero economic sense for a single bottle of water.
And it's not just the cost. RFID has a bit of an Achilles heel, and it all comes down to physics. Radio waves really don't play well with metal and liquid. They bounce right off metal surfaces, and they get absorbed by water. That makes it super tricky to tag things like cans of soda or big metal barrels unless you use special, and you guessed it, more expensive tags.
Okay, so this brings us to the final stage in our evolution. We've gone from people typing numbers, to scanning barcodes, to reading tags right through a box. The next step is a huge one. It's moving from just knowing where an item is to knowing how it is, in real time. We're talking about a supply chain that can literally feel.
Look, barcodes and RFID are fantastic. They are masters of check-in and check-out. But what about that long, lonely road in between? That blind spot when goods are in transit? That's the next great frontier in logistics. And the solution is the Internet of Things, or IoT.
Let's just walk through a little story about a medicine shipment. The old way, you'd have a little data logger in the truck just recording the temperature. If the fridge fails halfway through the trip, nobody knows. You only find out when it arrives, and that multi-million-dollar cargo is completely ruined. But with an IoT sensor, the moment the temperature starts to rise, it sends an alert to the driver and to dispatch. The problem gets fixed mid-journey, saving the cargo. It's the difference between a post-mortem and a life-saving intervention.
And this goes way, way beyond just temperature. IoT sensors are basically giving the cargo its own set of senses. An accelerometer knows if a pallet of fragile servers has been dropped, a tiny light sensor knows if a container door has been opened somewhere it shouldn't be, and geolocation can tell you instantly if a truck is veering off its secure, approved route.
So what's next? What's the future? Well, it's about taking the brain out of a central office and putting it directly on the truck. With new tech like 5G and edge computing, the vehicle itself can analyze all this sensor data and react in milliseconds. We're talking about preventing an accident before a human back at HQ could even get an alert on their screen.
This quote just perfectly captures the entire journey we've been on. We've moved from just reacting to problems, like a lost package, to building these proactive systems that can literally sense the world around them and fix problems before they even happen. The supply chain is no longer some black box. It's becoming a living, self-managing organism.
And that leaves us with one final, kind of mind-bending thought. We started this journey with a simple barcode that could only say what it was. We're now heading towards a future where every single object can report its location, its condition, its entire history. So the question is, when every object has a story to tell, what are we going to learn?